Okay, probability question here. Let's see, so there's two boxes that appear to be identical. They reach in and they select. One box has this in it, and the other box has this stuff in it. Okay, so we know what's the probability that a contestant will win $1,000. Well, the contestant gets to pick the box at random because they're identical boxes, right? So it depends which box they pick as to what their chances are of winning $1,000. And when I hear something depends on something, typically I'm thinking a tree diagram. So I'm going to say box 1, box 2, and there's a 50-50 chance, right? So then box 1 has 4 hundreds, so 100 and 1,000. So that'd be, there's 5 of them, so that'd be 0.20 and 0.80, right? 20% chance for each one. Box 2 has 4 envelopes, 100 in one of them, and 1,000 in the other 3, so 25% and 75%, right? Since there's 4 boxes total, 3 are here, 3 out of 4 is 75, 1 out of 4 is 25. Here there are 5 envelopes, 1 out of 5 is 20, 4 out of 5 is 80. Oops. Okay, so now what does question A ask? What's the probability that a contestant wins $1,000? Well, to win $1,000, you have to pick the probability to pick box 1 and then the $1,000 envelope, or I'm going to add them, or you pick box 2 and get the $1,000, right? So in other words, you get to go, you pick this, or you pick this, right? So the probability to pick box 1 is 0.5, and $1,000 is 0.20, or pick box 2 and times 1,000 is 0.75. Okay, so let's do 0.5 times 0.2 plus 0.5 times 0.75 is 0.475, or 47.5%. B. Let's see, if a contestant wins $1,000, what's the probability that it was the only $1,000 envelope in the box? So what's the probability that they win $1,000? What's the probability that was the only one in the box? That means they picked box 1, given won $1,000, right? Given that they won $1,000, what's the probability it was the only one in the box? That means they picked box 1. So this is the probability of A given B. And you actually have a formula for that in your formula sheet as well, but it's probability of A and B divided by the probability of B. So that's going to be the probability that you do box 1 and win $1,000 times 0.20, right? Over the probability that you won $1,000. Well, that could come on either one of these orange lines, which is actually this right here, 0.475. Okay, so let's go ahead and do that. Okay, and if you do that, that's going to be 0.21 or 21%. Okay, we haven't done these in a while, so if you're a little rusty, that's okay. We're going to review it before the AP test for sure, and before our final exam. Okay, so what are the expected winnings? Okay, well, if X are my expected winnings, what could I win? I'm either going to win $100 or $1,000, right? So if I win $100 or $1,000, there's no other option. Well, what's probably I win $1,000? We already figured that out. That's 0.475. Oops. All right. What's the probability they win $100? Well, I could go the top or the top, right? But I already know it's either one or the other because I'm winning one of those two. So it's going to be the complement of that, 0.525, right? So now the expected winnings, or my weighted winnings, or my average winnings, sometimes we call it mu, is 100 times 0.525 plus 1,000 times 0.475. Okay. And you get $527.50. Again, you're never winning that much, but if you play this game repeatedly in the long run, you're going to, on average, give out the average will be $527.50 per person. All right, there you have it.